Okay, just as a matter of identification, this should be lesson 3 of learning how to do programming on Android, and specifically game programming. So in lesson 3, we're basically to the point where we've got our environment set up, and we've done sort of some sample drawings. We've basically started up the emulator for Android, and although you shouldn't have a creature yet that's doing anything, in my example here, because that's what we're going to cover today, my dude is raising his foot up and down. Not very impressive, but hopefully a good first start. So, anyway, to get from drawing something on the screen to actually having it do something this ridiculously small is actually kind of a big leap. And so I'm going to try to break this session up into 2 parts. And those 2 parts should cover basically, well, the first part, this part, should introduce you to the concept of threading, which is sort of a in and outside of making a game. Understanding how threading works is sort of one of the key things to becoming sort of a real programmer, I would say. You can do programming without understanding threading, and lots of people do, and I'm going to show you how you can do that in this lesson, I hope. But threading is really important, and especially if you want to make games. If you want to make games where you got stuff going on the screen, and you got users doing things, and you've got artificial intelligence, maybe, you know, bad guys in the game trying to kill your character, or other race car drivers, etc. You've got to know how to do threads, and I'll explain why here shortly. And I should add, as I've said so many times in class, and so many times just before in this lecture, that, or in this course, that you shouldn't always expect that you're going to understand everything the first time. And the first time I explain it, or the first time you read about it, or the first time that you take a stab at understanding it. And sometimes it's not a failing not to completely understand everything that's going on, but to understand enough to do what you want to do. So I'm going to try to give you a really broad overview, and some of it you're going to understand, and some of it you might not. But don't be discouraged by that. Try to focus, and I'll try to help you during the lecture understand what is essentially vital to know, and what is more of a broad overview. I think the broad overview is good, and a good thing to have in here, and I think that you should strive to understand all of it, but don't feel frustrated if not all of it makes sense. Okay, that being said, let's get started, because we've got a lot to cover. Let's see. First off, you can think of a computer program, or basically everything that's going on a computer at any one time are a bunch of lists of instructions. So I drew up some examples here of like a set of instructions, and you could think of this as being basically a computer program. So first off, okay, we've got instructions on how to wash 3 cars in the driveway, and I added the 3 cars thing because I wanted you to see like sort of see how a programmer thinks about a problem. And usually when you're writing code, you're trying to solve a problem that you have to do or you want to solve a bunch of times. And so in this case, if we wash 3 cars, there's some part of this process that we're going to want to repeat. So starting out, we got some basic things that we need to do first. Get a bucket, get some soap, get a sponge, go outside, turn on the hose. And then after that, for each car that we need to wash, we need to do the following things. Fill the bucket with water and soap, rinse car, scrub car with soap, rinse car, dry car, pour out dirty water, and then we basically repeat the process. So for each one of these, we're going to do these things. And in our case, we'll do them 3 times. You know, obviously inside a computer program, you could have it do, you know, basically run infinitely until it's stopped, or the computer explodes, or, you know, all sorts of things. But in our case, you know, we started off knowing that we wanted to do 3, and we did it 3 times, and then the instructions are over. And basically, what you can think of, basically the way you need to think about this is there are, at any one time, potentially hundreds or even thousands of these lists of instructions going on inside a computer. And not only that, but I drew this picture to sort of describe the process. Well, let me also add this. There are lots of these lists going on at any one time, and the computer is, you know, obviously so fast if it's working correctly. You know, I'm sure that everybody's worked on a really slow computer and been trying to do a lot of things, and it seems like the computer's just freezing up. But in general, the computer is fast enough to switch between these lists of instructions. So here I have another set of instructions, how to bowl. And if you basically follow this little formula here, and I'm not going to go into all the details of it, I mean, this basically is all the rules that you need to bowl a game that has 10 frames, and doesn't go into any of the scoring or anything, but basically these are the instructions to bowl a complete game. And so if these were 2 lists of instructions that the computer was trying to do at one time, you know, it would basically say, you know, as an example, and this is not exact or anything like that, it sort of depends on a lot of things, how fast this is happening and how many instructions it will do from each list before it switches back and forth. But it might do, okay, get a bucket, get some soap, and then, you know, almost instantaneously it says, oh, what do I need to do over here? Pick up a ball, put on gross bowling shoes, okay, and then it'll switch back over here. And you can think about, you know, it's doing this with probably 100 different, I don't even, you know, a great number of lists on your computer. In fact, if you go into Task Manager here on a Windows computer, there's different ways to do this on every computer, but if I look at my list of processes, how many do I have here? 99 processes running right now, and you can basically think about, well, it's actually even too simple to say that each one of these is a list of instructions that the computer's doing. In fact, each one of these processes itself can have multiple lists of instructions within it. So it's actually, when you really sit back or stand back and think about it, it's pretty impressive what a computer's doing. At any 1 minute, millisecond, it's switching between, you know, potentially thousands of lists. And, you know, the bigger the computer, the more intense the work it's doing. I mean, if you have some kind of NASA supercomputer trying to find artificial intelligence or something, you know, that thing could be switching between all these lists of instructions at a rate that, you know, just staggers the imagination. So anyway, so at any one time, I drew this picture. to sort of describe what's going on a computer. You can think about a computer, and it's running various programs, and each one of those programs is